Let's take a look at this example. Please realize that we have two different diodes connected parallel. We have silicon and germanium. Anytime you are going to have a problem like this, when the two different diodes are connected in parallel, you're supposed to remember that the current is very lazy guy and is going to take always the easier way to reach the ground. It's much easier for current to jump over the transition voltage, right, of the germanium diode, because it's just 0.3 volts, than transition voltage of the silicon, which is 0.7. Okay, so current is not going to see this diode at all. Okay, so we can just say that this diode theoretically is not existing. Okay, so the whole current will go through the diode. And please notice that output voltage, right, is the voltage taken from the germanium diode, across the germanium diode. So it means that if the diode is in the on state, and it is on the on state because current is going to be pushed, right, by the voltage source clockwise, okay, and the direction of this current is exactly the same direction like the arrowhead of the diode symbol. So, and this voltage is much greater than 0.3 volts. So this diode is for sure conducting. So the voltage out is equal 0.3 volts. I can say V out, VO or V out, it's the same thing, is equal voltage at the germanium diode, and this is equal 0.3 volts. Next, we're supposed to find the voltage across the resistor. Okay, so VR I can find from the equation, right, KVL equation, and someone is going to ask why you want to write the KVL equation if the voltage is very easy to find. You have to learn how to write the KVL equations. They are very important when you are going to solve more sophisticated problems. So that's why I'm going to write the equation for this simple problem. I'm going to start from 0, okay, from ground. So I have negative voltage source, and because current is going clockwise, I'm going to put positive sign over here and negative over here and positive over here and negative over here. So I have plus VR plus VGE is equal 0. I'm looking for voltage across the resistor. Voltage across the resistor is equal voltage source minus VGE. Simply I solve this formula for VR. So VR is equal voltage source 9 volts minus 0.3 volts is equal 8.7 volts. So this is the voltage across the resistor. Next, we're supposed to find the current which goes through this resistor. Current IR is equal VR over the resistance, where VR is equal 8.7 volts over the resistance 3.3 kilohms. So IR is equal 2.63 milliamps. Right? So this is the current which goes through the resistor. Please notice that we are talking about the series circuit, okay? Because this diode, we said, is not existing, so we have series circuit. In series circuit, we have just one current, so we can say that IR is equal to I germanium, okay? The current which goes through the germanium diode, and this is also equal 2.63 milliamps, okay? So, if it comes to the silicon, the diode is not conducting, so that's why we say that I silicon is equal 0 amps. And this is the end of the problem.